Welcome back, learners. This is your Mathster, Nicole Anadon, ready to assist you with your studies, homework, and assignments in the field of mathematics. We are now in the second quarter of our 10th grade journey. Previously on our channel, you have learned about circles and their parts, arcs, and central angles. But for today's episode, it is time to level up our knowledge as we proceed to prove theorems related to chords, arcs, central angles, and inscribed angles. Of course, it is with great pleasure to give credit to the Department of Education and the Cordillera Administrative Region for providing Filipino learners with quality, convenient, and accessible mathematics modules that we are using as the basis for our video lessons. At this juncture, let us prove the theorems that we used in the previous module. Let us start with the following concepts.
Observe the picture that is currently shown on your screen. We know that the word congruent in mathematics means being identical in shape and size. Congruent circles are circles with congruent radii. For example, line XY is the radius of circle Y. Line AB is the radius of circle A. And if line XY is congruent to line AB, then we suppose that both circles Y and A are congruent to each other. Observe. Congruent arcs are arcs of the same circle or congruent circles with equal measures. In circle I, if the measurement of arc TM is equal to the measurement of arc KS, then arc TM is congruent to arc KS. Moreover, if circle I is congruent to circle X and the measurement of arcs TM, KS, and KZ are equal, then arcs TM, KS, and YZ are congruent. Theorem number 1 says that uncircled or congruent circles, two minor arcs are congruent if only if their corresponding central angles are congruent. Take this for an example. In circle P, since angle LPM is congruent with angle LPN, then arc NO is congruent with arc ML. But how can this be true? To prove this, here is a two-column guide. The statements and reasons form a logical progression, with each step building upon the previous ones to establish relationships between angles and arcs in the given circles U and K. Theorem number 2 says that a circle or congruent circles' two minor arcs are congruent if and only if the corresponding chords are congruent. In circle P, chords BA and CH are congruent. Since the two chords are congruent, then arcs BA and CH are congruent too. Given the congruency of circles T and N, and chords A and D and OA, let us use a two-column proof to see how arcs at AB and OE are congruent. As you can see, the statements and reasons all arrive at the same conclusion. Next, Theorem 3 says that a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. For a much more concrete example, we have circle M with diameter QR bisecting chord ST and arc ST, since diameter QR is perpendicular to chord ST. To prove the segments and arcs are congruent, here is a two-column guide to show that diameter AC bisects chord JM and arc JM.
Now, what about theorems related to arcs, chords, and inscribed angles? Inscribed angle is an angle whose vertex is on the circle and whose sides contains chords of the circle. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. An inscribed angle may contain the center of the circle in its interior, may have the center of the circle one of its q sides, or the center of the circle may be at the exterior of the circle. To clearly illustrate them, let us have these three examples to clarify them.
Theorem number 1 says that if an angle is inscribed in a circle, then the measure of the angle is equal to 1/2 the measure of its intersecting arc. If the measure of arc AT is equal to 120 degrees, then the measure of angle ACT is equal to 60 degrees. Theorem number 2. If two inscribed angles of a circle or of congruent circles intersect congruent arcs or the same arc, then the angles are congruent. In figure number 1, angle PIO and angle PLO intersect arc PO. Since angle PIO and angle PLO intersect the same arc, then angle PIO and angle PLO are congruent. Theorem number 3. If an inscribed angle of a circle intersects a semicircle, then the angle is a right angle. And central angle O, angle NTE intersects arc NSE. If arc NSE is a semicircle, then angle NTE is a right angle. Theorem number 4. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. If quadrilateral DRAE or DREA is inscribed in central angle L, then measurement of angle RDE plus measurement of angle REA equals to 180. Here are some examples. Example number 1. Triangle GOA is inscribed in central angle L, and the measurement of angle OGA equals to 75, and the measurement of arc AJ is 160 degrees. Find the measurement of arc OA. Number 1. The equation states that the measurement of arc OA is half the measure of angle OGA. Number 2. You substitute the value of 75 degrees for angle OGA. Number 3. The equation is then simplified to 75 degrees equals 1/2 of measurement of arc OA. Number 4. To find arc OA, you isolate it by multiplying both sides by 2. 2 times 75 degrees. This simplifies to 150 degrees equals measurement of arc OA. Measurement of angle GOA. The equation states that the measurement of angle GOA is half the measure of arc AJ. You substitute the value 160 degrees for arc AJ. The equation is then simplified to measurement of GOA equals 1/2 times 160 degrees. Find the measurement of angle GOA, we multiply it by 160 degrees, resulting in measurement of angle GOA equals to 80 degrees. Measurement. Example number 2. Quadrilateral fig is inscribed in central angle H. If measurement of angle AFT equals to 75 and measurement of angle FEI equals to 98, find the measurement of angle TIA. The equation represents the sum of the angles angle AFT and the measurement of angle TIA in the triangle. You substitute the value 75 degrees from measurement of angle AFT. The equation is then simplified to 180 degrees and equals 75 degrees plus measurement of angle TIA. To find the measurement of angle TIA, you isolate it by subtracting 75 degrees from both sides. 180 degrees minus 75 degrees equals to measurement of angle TIA. This simplifies to 105 degrees equals to measurement of angle TIA. Represents the sum of the angles angle FEI and angle FAI in a triangle. You substitute the value 98 degrees from measurement of angle FTI. The equation is then simplified to 180 degrees equals 98 degrees plus measurement of angle FAI. To find the measurement of angle FAI, you isolate it by subtracting 98 degrees from both sides. 180 degrees minus 98 degrees equals measurement of angle FAI. This simplifies to 82 degrees equals measurement of angle FAI. Now,
Great job, students! You made it until the end of our lesson. If you enjoyed our videos, don't forget to like, share, and subscribe to our YouTube account. Once again, this is Nicole Anadon, ready to assist you in unraveling the mysteries of numbers, equations, and mathematical concepts. Until next time, goodbye!